Okay, perfect. So welcome everybody to the, what month is this? May's Limerick.net and Azure user group. Delighted to welcome Matteo, colleague of mine at Avanade, and I'm probably butchering the pronunciation of your name, so I'll let you correct me, but take it away.
You're actually pretty bang on the manical. Hi everyone, I'm Matteo. I'm the head of software engineering for Avanade UK in Ireland. So I work in a department of the organization that is very, very close to what Carl does, yet we're very tangential. We're very close, but we're not touch. I work in London, but I'm Italian originally. I'm also Microsoft MVP in Azure DevOps and GitHub. And today I want to talk about what, as I said earlier, I believe it's one of the most important things that we can think of in this day and age, secure supply chain. So we'll find out that more often than not, problems don't necessarily come from our code, but it's about secure supply chain. So I love pizza, and obviously part of it, I'm Italian, so pizza is in my DNA and probably in my veins. But at the same time, everybody loves pizza, right? I only met one person in my lifetime that didn't really like pizza, but one out of God knows how many thousands of people, that talks volume. Pizza, if you think about it, is very, very similar to a software system. And I know it might sound weird because it's 8 o'clock and we might be a couple of pints down, but it is actually true because these systems, in this day and age in particular, are very much like pizza. You start with a base, you might have your infrastructure, you might have your networking, you might have whatever that makes your application tick. It could be your public clouds, it could be a multi-cloud setting, it could be anything really, okay? But you got your base, your infrastructure. On top of it, you got some source. And your source could be, well, whatever, right? It could be some configuration. It could be your custom, your custom logic itself. It could be a mixture of commercial products cobbled together, integrated via, I don't know, service bus or integration platform or whatever. On top of it, you have your cheese, which keeps everything together. So imagine you have a traditional application. Patching is one of the things that keeps the application running. That's your cheese. And on top of it, we've got toppings. Those toppings are your unique flavors, your unique functionalities that you bring to the table. So if you're developing a .NET application, chances are you're using a certain stack, which is base, source, and cheese. Repeatable? Perhaps. But your toppings is what's going to make your application unique. Now, ingredients matter, right? Ingredients matter. And as I said, it's important because your topics might be the application and the logic, but underneath, you will use a combination of things. You will use a combination of products, you use a combination of technologies, and you use a combination of third-party ingredients. And that's very, very important. When we talk about these ingredients could be commercial, open source, homemade, or anything in between, right? And that is very much true. I know I can't ask you to raise hands, but I'm pretty sure that each and every one of you in the call will have at least an application that uses, at the very least, one library. And it's a library that you don't control. It's a library that you don't own the code for, that someone else maintains. Now, ensuring quality and security is obviously paramount. And I've been in the industry for long enough to remember that companies used to run, the usual yearly penetration testing exercise, which was deemed enough. It usually gives a big book of findings. Some of them are addressed, matter of priority, probably not. Some others, they will be fixed over the course of a year. It's technical debt. Technical debt can be addressed, but over time, those findings will fizzle out, and we're back to the, in the yearly cycle. There's going to be a new pen test. There's going to be new findings, etc. Now, what we know is that if we control the code, that is easy. However, we are losing control big time. Like, think about how many dependencies your average application uses. A lot, I can tell you. Now, think about developers who tend to pick up any form of package, nuggets or a wheel in Python or whatever, NPM, you name it. They tend to pick up any form of dependencies because they're trying to solve a problem. They might have their own ready-made scripts, they might have their own ready-made solutions, or they could go and try something else. Over time, and that's very important, over time, systems become full with these dependencies. And those dependencies, more often than not, unfortunately, are not kept up to date. Vulnerabilities are always around the corner. And I like to bring up this vulnerability. It's not a security vulnerability per se, but it is a dependency that broke so many applications. And you will find the link in the deck that will be shared. But basically, this programmer wrote a library that shifted left some tests. It's just some padding, right? However, it's been used in so many applications. One day, the developer decided to remove the dependency from npm, and so many applications were broken. Now, this is not a security problem, obviously, because it's some text that's broken, can be fixed fairly easily. Yes, a couple of days of panic, but all in all, easy to fix. However, it really was the catalyst, and it exposed the fact that we're using too many dependencies and we're using them with no control whatsoever. Now, think about it. If you find a bug during requirements or architecture definition or anything that is pre-industrial coding, if you like, pass me the term, right? We're between friends, so I'm not using the exact terminology, but if you find a bug and you fix it when you don't have an application in a fully formed state, that is obviously way cheaper than actually fixing a bug while you find it in the code, right? Because if you have your application, imagine you have your application, you are rushing through your timelines, you're rushing through everything because you really, really need to release. And you get to an MVP version, a very early preview version because your client, your stakeholders want to see it. You know that it works. You know that it's fine. You find the bug. Now, it's already way more expensive than fixing the bug when designing the product. However, it is remarkably cheaper than a bug that's found in production because for each of the traditional stages, and bear with me, I'm a big agile advocate, but this is to simplify the various stages, and also it comes from the NIST. It's an Institute of Standards, so they try to standardize around these well-known terms. Essentially, the moment where you move away from still having unfinished code towards a production system, the cost goes up exponentially. And if you find a bug in production, something like left pad or something like Log4j, to name one, that is an incredible problem. Now, more often than not, security is not really considered in the requirements. More often than not, we have teams that receive requirements focused on an acceptance criteria, which is functional in nature. You might have all the various abilities, the observability, you might have performance, you might have all the stuff, all the non-functional requirements. However, everything is functional by nature. And the problem is that the security aspect is more often than not overlooked, not just in our own code, so in the way that our developers work and produce code, but also in the dependencies that are used, because I'm pretty sure that unless I am incredibly lucky, less than 50% of the audience has used a software bill of material. I'm pretty sure Carl can correct me if that's not the case. Now, secure coding practices are obviously extremely important, but solutions should always emerge from the team. You don't want to be in a situation where someone just pushes down a new tool, a new code, a new piece of code, a new practice or whatever, because it doesn't really work, right? Solutions should always come out directly from the team. And an example of that is secrets management. I'm sure everybody saw that, right? We all know that no secret should ever go in a code repository, either a username, a password, a token, or anything really, right? But it happens. Now, what's the way of preventing it? The easiest way is the frictionless way. In this case, for example, if you use Azure Key Vault, you can link a key vault to your pipeline, and your pipeline will automatically download all the secrets, making them available as variables into your pipeline run. So that over here, if you have, rather than just key, you have username, password tokens, PATs, any form of secret, or even just configuration strings, that is something that can be automated in a frictionless way, avoiding any form of manual interaction, and also knowing that there is a single point of truth, a single source of truth, I should say, for all these values. something this simple, which is setting up a key vault with no special configuration. Yes, you can configure it with virtual network injection and so on, but if you've never done it and you're still managing secrets out of band and hopefully not in your code base, the way of preventing secrets ending up in a code base is to set up something like this, including it, integrating it into your pipeline execution environment. And in this case, for us, let me see if this pen actually works. No, it doesn't. But these linked secrets from Azure Key Vault as variables is extremely important, because Azure DevOps will automatically set up these tasks. You will not see them. They will just happen. And all the variables will be mapped to, all these values, sorry, will be mapped to $ name of your variable. So the convention is transferred over. It's all nice, but many threats are unfortunately external. And you really need to monitor your supply chain, because exploits are out there. And the bigger the framework, the more important the framework, the worse it is. We will see a few examples later on, but think about it. If you use a small, relatively unique library, you have a number of options. You can get in touch with the developer directly. You can replace the code. You can contribute to the code and make it better for everyone. You have a number of options. Everybody will welcome a contribution, right? Especially if it's a small library. However, if it's a big library, chances are that things might be more complicated. The library might be commercial, for starters. A small library, even if commercial, you might have better access to their development team. For a larger library, things might be more complicated. If the library is open source, you have natural competition with all the other feature requests and bug fixes and contributors. And you might never know what could end up into your manifest and into your applications, because unless you have a way of vetting the supply chain in a way that is monitored and is carefully controlled, you cannot guarantee that that version of jQuery is actually that version of jQuery. Now, think about it from this perspective. Your code is the easiest possible thing, because your code is yours. It's easy to patch, easy to manage. You can, decrease technical debt as needed. You have a number of options at your disposal. Then you have two fronts to look at. You have the external services, which again, they are easy potentially to replace, because if they're not essentials, you can replace them. You can put something in-house that does the same thing, all sorts of things, right? However, if the external service is essential, then you need to build some form of validation, perhaps, towards your code, so that you know that your service is actually who the service claims to be. And it will always return a certain data structure. It will always interact in a certain way. However, this is still better than actually having proper implicit dependencies, which you have no control over. Because the question is then, do I trust my suppliers? And again, a supplier can mean so many things, right? Also, it's up to you to make sure that whatever the supplier provides, you use. So let's have a look. I talked for long enough. Let's have a look at a couple of examples. A legacy code base. Is there any question in the chat in the meantime?
So far, so good. We've had another attendee, as you can see.
Hello. Bringing the numbers up.
Yeah, bringing the numbers up. He's supposed to be asleep,
Brilliant.
but we'll argue about that later. No questions so far, Matteo. Thank you very much. Just the thing to point out here is that you made the point about software developers and this code or software supply chains and stuff. The more that the infrastructure side of the house adopts DevOps methodologies, the closer we are to software development, the closer we are to those sort of practices. So this is as critically important to software developers and software architects as it is to those on the infrastructure side of the house. So great session so far. Thank you.
Just 2 words on that matter. Terraform and Ansible. All I'm going to say. Now, if we look at this is Parcel Limited. It's an ASP.NET 4.5 application, so a legacy application, right? You can tell from the date of the last changes, and that is done on purpose. Obviously, we never really wanted to bring new features out, and I picked up this version in particular because it's something that I know builds fairly stably, yet it has some problems. Now, building the application, and if we go and have a look at the pipeline, actually, before we go and have a look at the pipeline, the code is very straightforward. It's a standard ASP.NET 4.5. It doesn't have anything fancy. It's an MVC application, so relatively modern by all things considered. And it's got obviously a number of packages which are used. This is the manifest for. This is the manifest for the packages file, for the Nugget packages that are used. And as you can tell, .NET 4.5, so old stuff, but still, so many organizations as of today, they still work very well with this technology. Sometimes you don't need to modernize. Sometimes you can't modernize. There's a number of reasons. Like this is obviously a bit of an extreme example, but at the same time, in the market, there are so many examples like this. Now, in my pipeline, and my idea is that anything should be as frictionless as possible. So if we look at the pipeline that builds this application, this pipeline is extremely simple. And obviously, it doesn't deploy anything, right? That's by design because it's a simple demo. But it's the standard ASP.NET build and test pipeline with a couple of additions. I added SNCC, and I added Sonar Cloud. Now, this doesn't know anything else, right? SNCC is going to scan the code, and it's going to scan the packages which are part of my application. And then Sonar Cloud is going to analyze, well, it's going to scan the application, analyze it, and publish the results. Aside from that, nothing else. Now, SNCC is interesting. We're going to get back to that. But SNCC is obviously going to tell me, look, you have a huge amount of things that are outdated because it's designed to look at supply chain. However, it is worth looking at the broader perspective that Sonar Cloud in this case brings over, right? Sonar Cloud is a code quality platform, and it is one of my favorite platforms in this space. No problem getting on record. There are other platforms like Q1, for example, a pretty good one as well. But over time, Sonar Cloud, you get used to it. Maybe it's a comfort thing, but I ended up getting a lot of good results out of Sonar Cloud. The same goes for others, don't get me wrong, but it's a matter of habit at the end of the day. So if I look at this application, and again, this was purposely analyzed a while ago. It's been done in a way that simulates legacy code. There's a number of things that are raised. Obviously, a number of bugs, first of all, and those bugs can be something very minor, or it can be something considered critical. It very much depends. And there are rules and considerations to make when it comes to Sonar Cloud, but it could be stuff like duplicate properties in the CSS file, probably not the most important thing. However, interestingly enough, if we start looking at where the problems are, besides the code smells are about maintainability. We have a number of security vulnerabilities, and this is one of the things that Sonar Cloud does. So in this case, I'm looking at the controllers, and there's a number of things that are being raised in the controllers, like, for example, not having input validation for the post method. And this is something that you see it is replicated throughout. So there's a lot that can be fixed with relatively small effort. But what is really interesting is that we start looking at the hotspots. And in the hotspots, you will find stuff in your JavaScript files, right? Now, this is interesting. Obviously, there's a lot of replication here, but there's also a risk for remote code injection, which is an interesting one, and it comes from a modernizer script. There are a few points on weak cryptography, and there's another couple of relatively minor things. Interestingly enough, though, if we go and look at the structure of the code base and the results that Sonar Cloud brings over, remember, this is a pretty legacy code base, right? If we look at the dates created around November 2015, updated in November 2021, multiple updates here and there, but at the same time, this is not modern, performant, latest and greatest code base. This is something that evolved throughout the years with legacy tech. If I start looking at the code, this is where it gets interesting. So ignore the code smells for now, because they are about maintainability of the code, etc. Look at the vulnerabilities. Yes, there are some in our controllers, but it's not a big number. The interesting thing is the number of bugs and the number of security hotspots, most of them into the scripts folder, which is where our JavaScript dependencies live. If I open this up and I start looking at them, I will see that the biggest culprit, obviously, is an old version of jQuery. And this is where it gets interesting. Think about it. jQuery, it was used left, right, and center, and it is something that's still very much in use. You might not think about it because, oh yeah, jQuery is fine. jQuery is not fine if it's an old version. jQuery is not fine if it brings 11 security hotspots. And we start looking at the code, because you can look at the code being a script, and you will see that there's a number of things which will be raised by Sonar Cloud. That's automatic because of the type of rules that I use, and obviously you can tweak them as needed. But the important thing is that you can have this high-level overview for your code base so that you know if there is something going on, what is it that I should be aware of? How can I track this? How can I make sure that these get addressed? Very important, right? And it is something that as developers, it's important to keep under control. Yes, there are tools in the IDEs, but they end up being personal tools in a way because everybody will use them differently. Now, if you're a team leader or engineering manager, my recommendation would be to add as many things in the CI/CD pipeline, because what happens is that those tasks, those steps will be fully automated, which means that they will all go through, every developer will go through the same process, and every developer in this case will go through these steps, which will include running Sonar Cloud and running Snyk. Now, if we look at legacy code, again, this is another piece of legacy code. It's a simple calculator, right? It doesn't do anything beyond doing calculations, and I can show you the actual code because the code is pretty simple. It's an old application that uses, oh, look, there's a secret here. It's an old application that uses Launch Darkly. It uses, ASP.NET, not even MVC. Yeah, it is MVC, but it does sum and subtractions in a fairly complicated way. Obviously, that's done on purpose. But the idea is that all of those things, they might be questionable, yeah, but all of those things will be raised by Snyk because it's using an old version of .NET Core. This version of .NET Core, yes, it's the right one. This version of .NET Core is vulnerable to remote code execution because there is a well-known vulnerability in this version, which it was fixed in .NET Core version 2. So it's a pretty old piece of code, and it would be a good idea to fix it because otherwise you are vulnerable to this. And being vulnerable to remote code execution this day and age leaves a lot of doors open. Other things could be something like ASP.NET Core MVC being open to denial of service attacks. But again, this is an old version, right? So it's something different. It's denial of service. It's not remote code execution. And interestingly enough, Snyk doesn't have an example. It doesn't have a known exploit or proof of concept or whatever for this vulnerability. It's known that it exists because it's linked to a CVE. So if we're going to look at the CVE, we can see the actual vulnerability being documented, etc. So the vulnerability exists, but there's been nothing up to this point which is known to have used that. Now, compared to the remote code execution, which has got a published code exploit for this vulnerability, this is very concerning, and it should be something that everybody should be addressing as soon as possible. Other things, obviously lighter, but what's really nice of this tool is that if you want to fix stuff, if you can fix these vulnerabilities, and more often than not, they are fantastic. Yeah, I couldn't find any running credentials anymore, but basically, more often than not, if it's dependencies, they can be fixed with a PR. The PR will trigger a build. The build will have tests. You will quickly validate and iterate whether a fix is possible this way. And it saves so much time and so much effort, which is unbelievable to think of. Any question?
So, Matteo, are you building in, so think this is analyzing existing code bases, but are you building this stuff in as quality gates in your pipeline so that when your developers then submit, maybe you're about to get to that, and if so, tell me to be quiet. But are your developers then submitting a pull request and the pull request getting rejected automatically if it fails the
Yes.
quality gates?
Yes, absolutely.
Okay.
And that's
So
exactly how these tools should be used, because otherwise it's like using Azure policies in audit mode. You will flag a number
yeah,
of things, you're not preventing anything.
yeah, and one of the things that I've done in the past is use the likes for infrastructure as code. So use the likes of checkoff or
Yeah,
tfsec to do exactly that sort of thing, but on the Terraform side.
yeah,
Checkoff these days is owned by Palo Alto, I think, and TFSec Aqua Security. So if you don't use them, those in the chat, go and have a look at them and build them into your pipelines for spotting those security holes and those vulnerabilities in your infrastructure as code. Sorry, Matteo,
absolutely.
I'll let you
No,
crack on.
I was gonna bring them up because there are a few examples later on, but that's exactly it. So this concept can be applied to both code, as as in application code, as well as infrastructure code. Because these days, for what I'm concerned at least, anything and everything lives in a Git repo. If it lives in a Git repo, chances are it's code, chances are it's vulnerable. Now, there are other tools, right? It's not the only tools that we can use, but those are the most powerful, the most effective one, especially when you start implementing them as as quality gates, like Carl correctly said. Interestingly, there is a very good tool that is coming out, and it's Defender for DevOps. This is a screenshot of a preview version, but I think you can enable now. It's in private preview, if I recall correctly. But anyway, this is what it's going to look like. You can connect your Azure DevOps organization and your GitHub, your GitHub organization to your Azure tenant. You can let Defender for DevOps, scan everything in there, which means that you get this single pane of glass view where you can see the code scanning vulnerabilities as well as the secrets and the open source vulnerabilities that are all across your code bases. This is a single pane of glass view. So it does something that is very high level, very generic, very standard, but it gives you so much control over that because it's project by project. You can enable the pull request and you can see immediately if there is any secret exposed, for example. As I said, there are so many tools for code quality analysis. I use Sonar Cube and Sonar Cloud so many times in the past, but also Q1 is a very good alternative. As long as you check your code, you are doing something better than the past, right? Because scanning your code is one thing, but then actioning those information is extremely powerful, and that's what makes the difference. That's how you move from just auditing onto actually fixing things. Supply chain analysis, we talked about that. There's another tool called White Source. It looks like, well, it used to look like this. Now it is slightly different. It's got a different UI and it's got a different implementation, but in a nutshell, it does something similar to what we've seen. And again, jQuery is the culprit here in this screenshot. But the idea is that this application can go and look, and in an integrated fashion, it will look at the health of your code. It will also look at your distribution of licenses. It will look at the libraries that you use, and does an inventory of what you have available. Really, really powerful. And it's something that, again, should be plugged into your pipelines, because that's the place where you can validate all the control and all the application. Sneak, we talked about it. Then secret scanning. There are so many tools for doing secret scanning. I used to use Microsoft CredScan. Now it's integrated into Defender for DevOps. There are so many other tools available, open source and else. Please, please, please check for secret leakage, because if you find, you find a password, you find something, that password can be, a key to your system. And that's the worst possible way of being hacked, in fairness, because yes, you can have, so much technical data and ways of fixing it, but you might have the perfect system. If you have a token, a privileged token somewhere available in your code base, that's going to be a slam dunk. So please use a credential scanner. Now we're moving into the realm of SAST and DAST. It's very important. And I feel like it no longer gets, the treatment that it used to in the past, because in the past it used to be these extremely expensive set of scans that maybe run once a year and so on. Basically, scanning code bases became very rare over time, which is a bit weird in a way. But static security analysis, what it does is looking at your code and looking at your binaries to ensure that your binaries are secure. All right. So anything that is unsigned, for example, that would be a flag. Something that doesn't use secure settings or secure values or those kind of things, or all tools, even all tool chains, that could potentially expose vulnerabilities. And there are also well-known patterns for malicious behavior in code. So those tools will help you scan your code base to look for well-known patterns which are, significant in terms of malicious behavior. It's important because if you don't have control or full control over your dependencies, this is where you're catching rogue dependencies or things that could cause problems. And they will catch them very quickly. As you can see in an average build, 1 minute for a simple skimming test. That doesn't take too much. There are so many options out there, and I strongly recommend to look at SAST on a regular basis to make sure that things are under control. Then infrastructure as code, security validation. Very, very important. Check off TFSec. I used to use other tools as well from Microsoft. There are so many options available. But in a nutshell, you want to make sure that all the infrastructure definitions are scanned against reference implementations or configuration best practices. That is because you might have the infrastructure as code that does something, and then you configure the resulting infrastructure differently. But why, for example, you're not taking advantage of a secure default? That is something that is worth always keeping in mind. This is a good example, right? So you look at this scan and you say, okay, this scan is, it fails on a number of things. Some of the things, yeah, BCDR with always on an app service, I might not need it. Azure audit enable logging and monitoring. This might be a dev environment. I might not need that. But for example, preventing HTTP access, this is something that should be enabled all the time. You should not be exposing anything via HTTP. In the same way, you should always store secrets in key vaults. Absolutely, all the time. That is something that should never be read. Deploy user ARN template. This is a weird one. So this is a scan that raised that flag, but obviously that's because the ARN template was not fully executable. And this is an interesting result, right? Because thinking about it, yes, I'm using ARM, fine, but what if your ARM template is not executable correctly? This needs to be checked and controlled. Anti-malware, that's something that is never taken into consideration, but the question is, how do you know that you're not actually producing malicious code? There are, scanners on the market. There are antiviruses that can be used with an API. There's so many things. Build servers can be compromised, so you never know the environment that you're running against. That's very important. And every now and then, scanning what you're building, scanning what you are producing goes a long way. I've seen stuff being caught by an anti-malware scan because there was stuff that was checked into the repository without knowledge. It happened. It was a mistake. That was from a person that was experimenting with penetration testing. It was one of those things that he's just doing penetration testing. It ended up in there. It produced essentially a malware. Now, important to know, because if you're shipping that to clients unwittingly, and someone might end up exploiting those things, then it can become a big problem. So always run an anti-malware scan. And then we move to something like DAST, so dynamic application security testing, like OWASP. Things will run against a live application, so you will have a direct test against real behavior. This makes a difference more often than not, because aside from the fact that some of them can perform memory analysis, so they can scan memory and they can see those things, but it is really important because your application might be technically safe, but it might be opened up by unsecure default behavior or vulnerable code. So stuff that can be exploited that slips through the cracks. So dynamic application security testing ensures that your system, when it's running, will behave correctly. I always recommend to run a scan at least against the production environment on a regular basis, and also to put it part of every step of the way up to getting to production. Any question? I ran through very quickly to make up for time, but I realized that I ran way too much. Is there any question before we summarize a little bit?
Oh, sorry.
Very
Not,
good question.
yeah, well, okay. So no, we were just sharing some links to some of the products you were talking about in the chat, and then Alan's talking about PS Rule for bicep scanning and stuff like that as well. So
yes, brilliant. Yes, absolutely. There are so many tools, and that's why I haven't necessarily mentioned all of them or a list of them, because if you go and run a search on Google, you will find that there's so many things available. So it's very much up to you and what your team is used to and what fits better into the workflow. But in summary, keep an eye on what you use, because a team should definitely know what they're using. They should have a software bill of material. They should be able to reproduce environments from scratch, from inception until the commissioning. They will be able to have full control. It's important because today, literally anything can be used as an attack vector. Update your dependencies, do it regularly, make sure that you are on latest, don't pin library versions, because vulnerabilities will come up and you should not wait for a vulnerability to become a priority, like the examples that we mentioned earlier. Don't do that. Also, try to automate remediation as much as possible. Like, this is a very hot topic, of course, but you can have automatic remediation by automatically destroying an environment and redeploying it if it's been marked as tampered. That's something that can be done. Automation can save time also now with generative AI. There's so many things that can be done, but in general, make sure that if something happens, there is a path forward. Because if you don't, then you're stuck with a very expensive remediation effort. If instead you have a plan and you have some automations that will help you, like for example, destroying the pre-production environment, redeploying it from scratch because it was marked as compromised, that is a cheap way of getting out of a remediation problem. There are obviously other tools and other things that you can do, but as long as you have automations will help you saving time and increasing quality. And that would be all. Thank you very much for your time.
wonderful session. I think several of those topics could probably be sessions by themselves.
Yes.
And we could spend hours and hours talking about this, because I know I'm laboring this point, but infrastructure folks, non-devs in the audience, this is really important. The more you write infrastructure as code, the more you're going to want to sanity check, because don't sanity check yourself. Don't trust your mate to sanity check you. Get the automated stuff to sanity check you. Check for security holes. Check for gaps against best configurations. There may be reasons for those gaps. That's fine, but make sure that something is calling it out, and where possible, automate those remediations. Alan, that's a touchy subject, but yes, the more I work in tech, the more I think that everybody is a dev at heart. But don't say that on Twitter. I don't want to start a fight. So anybody want to come off mute and have a chat, ask Matteo some questions. So this guy, as he said at the top of the session, heads up Avanad's software engineering practice in the UK. So feel free to pepper him with questions, ask him about his session, ask him about his views on software engineering and PowerShell versus Bash, or .NET versus Python, Python versus Go. Just come ask some questions.
I think the bigger one is Terraform versus Bicep, isn't it?
Don't forget Pulumi and all of that.
Exactly.
No contest, Bicep wins.
You've got to be a developer to get Pulumi, but it's on my list when I learn a real language, right? That's not PowerShell. but now, over the last 6 months, I've been teaching myself quite a lot of Terraform, and I really like Terraform. I like Bicep too, but I really like Terraform. I've been really impressed with it in the last 6 months.
Can I be absolutely blatant? If
Yeah.
you're writing even a single line of Bash, PowerShell, anything, you're a developer. Full stop.
Them's fighting words.
Yes. anything does.
I think the issue with the developer sort of piece, as far as say IT pros, for want of a phrase, is it's not that like I don't have a problem with that tag, but it implies when they do content, they start ignoring the bits that the IT pros tend to focus on, i.e. infrastructure, in particular infrastructure as code, all of that kind of stuff. And then just focus on, oh, well, developer means somebody writing some C# or whatever, you know. And we are developers and we should be using some of the common things like source control, that kind of stuff, but ignoring the slightly different slant to what people do is not great. If you look at the Microsoft stuff in the UK, although unfortunately they've just got rid of somebody they shouldn't have done, but it was more developer focused rather than developer IT pro focused, and has been for quite some time, you know.
And that's why I like when a team actually has emerging standards, because everybody's got something to bring to the table. And personally, I've been involved with software development for 15 odd years at the minimum in a professional capacity. However, at home, underneath my desk, there's a 12-unit rack cabinet with still stuff going. So I've been on both sides of the fence, and it's very, very important that everybody brings their diverse perspective to the table. That's how teams get better.
Yep, 100%. And what you allude to there, Alan, that's with MVP or two on this call, I won't criticize Microsoft too much, but yes, Microsoft in particular have been a bit developer friendly or focused over the last few years. So yeah, I accept that should be accepted criticism, you know. But yeah, there are plenty of IT pros that they get irritated when they're called developers, despite the fact that we all write code and we all develop in some fashion. So without getting into that particular holy war, has anybody got any other questions for Matteo?
Just
Nick, you've
one
been very quiet.
question, an observation. Matteo, you give an example of sorry, I was bobbing in and out, so if I missed some of it, apologies, but you were talking about a vulnerability in .NET Core 2.1.
Yeah.
Surely that should be flagged up as something that is no longer supported full stop. So it shouldn't really be running anymore. I would have thought anything less than .NET 6 should be top of the list to, I don't know what you want to call it, refactor, update, who knows, but not running anything less than that.
Unfortunately, we don't live in the real world.
Yeah.
That's the thing. And we see them time and time and time again. Legacy systems, they are running, they keep humming along because they work. Nobody's there to fix them anymore. Nobody's there to enhance them anymore. However, this is a whole can of worms that needs to be considered.
Yep.
Yeah, in an ideal world, people aren't running that sort of stuff, but I've seen customers in recent weeks running Exchange 2010, Server 2008. You know, it happens, and it's up to us as technology advocates and technology engineers to encourage the movement, to encourage keeping up with technology and minimizing technical debt, because it's in their own best interest. It's going to cost them less money to support, and it's going to cost them less downtime when something inevitably gets nobbled, or when something gets when something just fails because it's old and not getting updated anymore. So it's up to us to advocate that stuff too. But you'll get enterprises who just view IT and tech as a cost center and not a business enabler, you know. And it's up to us again as advocates to encourage that change in thinking from cost center to business enablement. All right, anybody else? Any questions? Tomas, Nick, Yaz, JK, good to see you. They can't understand you. Here.
Go, Johnny.
Oh, it's nothing from me, but the thing is, just want to just completely agree with what you're saying about Sonar Cloud, for example, because the thing is, I used that in my last contract that I did and stuff, and just highlighting just some of the vulnerabilities of just even a small piece of development that was done that had been in production for such a long time. It was just eye-opening for the organization, and just implementing that, like the quality gates that you can do from a DevOps pipeline perspective. It was a huge eye-opener for the organization. And the thing is, as you say, the thing is, they looked at the dynamic code analysis element as well, but the thing is, it was a bit too soon for them. There was just understanding about the fundamentals about the static code analysis at that time, and just that change in their sort of thought process in terms of the development process. Just everything that you mentioned today, I just cemented everything that was in my head in terms of what organizations need to do. So I think I just wanted to say, awesome talk, really impressed with today and stuff. So.
Thank you. And also, I can tell you, Rome was not built in a day, and I can confirm that because I was born there. So let me tell you, it's true. But as soon as you start with awareness and you are aware of a problem, then you can start putting down steps and automations to reduce this problem. Over time, the gradual reduction of the surface of attack, the gradual reduction of the technical debt, that's going to be perceivable, because it's not something that happens in a spark and then disappears. It will become embedded into the fabric of your team and the organization, hopefully.
Definitely, and that's the thing. Even the gating thing, something as simple as that, people saying, "Oh, we can't deploy to UAT because of the fact that we that sort of thing." That was a big culture shift for the developers in the organization, because they were going, "Oh, whoa, it went through sit fine, went from dev to sit. Okay, how come? Oh, we missed this in terms of we need to change this, we need to do that." Even the things in terms of what you mentioned about the username and passwords that they kept in the actual configs and stuff. The thing is that the shift, even just utilizing ignore config within the Git and stuff. The thing is, even doing simple things like that and utilizing local JSON files and stuff for config. So the thing is, that sort of config doesn't deploy from when we do PRs and stuff. The thing is, that sort of culture shift was huge for them and stuff, and it was really good to see, just sitting back and developers getting excited about the fact that we've got this that can help us and stuff. And then the thing is, as you say, the IT pros that we talked about earlier, the thing is, getting them to say, okay, we from infrastructure as code, what can we do with that? Like all the tools that you mentioned today, those are still coming along and stuff when I left the organization. So no, it's all everything that you said today, definitely 100% agree on, and it's a really good place to be in. That the DevOps sort of plugin, what was it called? The Microsoft Defender for DevOps. I think it came out for GitHub probably about a year or so ago. There was some functionality within GitHub and stuff that would allow you that sort of.
Still is in the bot.
Yep.
Still there.
Yep, yeah, exactly. So the thing is, the fact that they're bringing it into DevOps is such a good move and stuff, because there's so many organizations with DevOps already ingrained within the organization, and having that built in, it's going to be awesome as well. So it's all good stuff.
Jazz, I think you'll find there's more stuff imminently due for arrival, and the new label for it all is NCAPP, I think, which encompasses that Defender for DevOps and a big pile of other stuff. So there's more coming.
Wicked. That's really good to hear.
Unfortunately, most of it's paid. There are some free bits as well, though.
Yep. No, cool. Thanks for that.
Awesome. We're approaching the top of the hour, so I'll thank everybody for joining us tonight, and thank you for tolerating our visitor, who hasn't been too noisy. Matteo, that was an awesome talk. Thank you very much. For anybody that doesn't know, I also help run another user group, the Azure Cloud Native user group, which, as it says on the tin, focuses on Azure Cloud Native, Kubernetes, containers, and all of that good stuff that I'll not quite start talking about tonight. But Matteo is joining us at the end of June 27th to talk about Azure app configuration and easy feature flags. So do sign up for that if you're on our meetup page. If not, have a search for Azure Cloud Native on Meetup. So thank you very much, Matteo. Appreciate it. Thank you, everybody, for joining us at LDNA. See you next month.
Pleasure. Cheers all.
Cheers.
Bye.
Thank you. Bye.
Bye.